Thank you, Cheryl. To begin our morning session, we're going to be hearing from Mr. Michael J. Turco. He's General Manager of the Harris-Galveston Subsidence District and Fort Bend Subsidence District. He will be speaking on the past, present, and future of subsidence in the Houston region.
All right. Well, thank you very much. Subsidence in our region has been an issue that we've dealt with for over a century, certainly long before Houston became the metropolitan area that it is today. But it's an issue that since the development of this area is something that's been a big issue for us as we developed and evolved, and Houston became this great place that everybody wants to live in and industry wants to come and do business in. All those practices require water, and as we'll talk about in a little bit, the extraction of shallow fluid, particularly groundwater in our area, is the primary cause of subsidence in our region. Let me do a little bit of house cleaning here first. I'm going to talk a little bit about the hydrogeology of our system and how that predisposes us to subsidence as it relates to groundwater withdrawal. And then we'll talk about some of the data that we've collected, the people that we work with, some of the history of subsidence in the region, and current rates of subsidence that we see today, and how all that fits into the regulatory structure that is the subsidence district. The subsidence district, the Harris-Galveston subsidence district, was created in 1975 by the Texas legislature after a lot of outcry of local municipalities, local industry, and local other agencies, particularly NASA, as subsidence rates and subsidence amounts in the area had reached large numbers to the point where we began to see inundation of coastal areas, and I'll show you some examples of that later on. So we began in 1975. We actually have a 19-member appointed board that are appointed by local officials, and I'd be remiss if I didn't point out that Miss Kathy Rogers, one of my board members from representing Galveston County, is here today. So Kathy, thank you for being here today with us and sharing the message of subsidence and regulation in the area. The Fort Bend Subsidence District was created in 1990 with the same mission, regulating groundwater withdrawal to stop subsidence in Fort Bend County. They have a 15-member appointed board. Our agency is not a taxing agency. All of our revenue comes from the fees on groundwater users. And our regulatory plan is developed in a way to allow a certain percentage of total water demand to be utilized with groundwater, and the rest of the total water demand, whatever that is, has to be based on an alternative source of water. In our area, particularly, that's typically surface water, although in recent years that's been reuse and other forms of alternative water. So subsidence, you guys have heard about this yesterday. Many of you in the room know what subsidence is. I'm not spending a lot of time on this, but one of the first cases that we saw of subsidence in our area occurred in Goose Creek oil field near Baytown back in the early 1900s, and I have a slide later on that shows that. In our area, it's about the compaction of the clays in the matrix of this aquifer. Our aquifer is an interbedded sand and clay. It consists of 3 primary water-bearing units that in this cross-section is very simplistically laid out. It looks very nice and ordered. The Chico here at the top and the Evangeline, these 2 aquifers are hydraulically connected, so water can move freely between them. The shallow system of the Chico and the Evangeline is separated by the deeper Jasper, which is primarily used in northern Harris County, but more so in Montgomery County. It's a transgressive, regressive depositional environment, an accretionary wedge of sediment that it gets thicker as you move towards the coast. On the y-axis, we have thicknesses here. You can't read that, but you're looking at thicknesses that, when you get down near the coast, get down into the 5,000 and greater feet of thickness. A lot of clay and a lot of sand. But the clay percentages are quite high, and it's those clay lenses that are of a primary concern to us as we begin to see water levels change and pressures change in this aquifer. So the mechanism for subsidence in our area has been well defined and studied by the U.S. Geological Survey, academics, and others over the last century. A lot of the work, the first documented case of subsidence occurred in 1929 at Goose Creek oil fields. For USGS documented the impacts of shallow fluid withdrawal there on the aquifer system and compaction. But there's 2 components to be concerned with, and there's the inelastic and the elastic component of compaction. So when all these sediments were deposited, They're deposited under pressure, and all these aquifers are artesian, which means before development, the pressure was above land surface. And over time, as development occurs and groundwater is withdrawn, wells go in, water comes out of the sands, and then eventually water begins to come out of the clays as those pressure gradients get bigger. It's that depressurization of those clays, which are initially all randomly orientated, flatty clay grains. You depressurize those, and those clay grains lay down. That compaction that occurs over 3,000, 4,000 feet of sediment, in some cases in our area, has resulted in 10, 15 feet of subsidence, which in a coastal environment is a bad idea. The inelastic and the elastic component is important in that the elastic component is what happens near the surface. And I don't know how many of you saw the quick Twitter article that came out from Cal Berkeley, from a postdoc out in Cal Berkeley, that used some of our Corps' geodetic station to estimate that about a centimeter or two of subsidence occurred because of the weight of the water from Harvey. Any of you guys see that article? Yeah, I got a lot of phone calls on that one. But that was an elastic response to the weight of the water, and from looking at the data, that's probably real. All that elastic response came back after the water went away, and so that elastic shrink swell is the same thing that we see in the summertime when the clay is compact and your driveway cracks, or when it rains a lot and your driveway cracks. That elastic component isn't the component that we're concerned with. We're concerned with what happens at depth, because once that compaction occurs at depth, there's no amount of energy you can put back in the system to pop those clays back up. You can't get the water back in there. You can't get the pressure back in there. That compaction occurs, and that subsidence occurs. It occurs forever. Some of the data will show that. Here's Goose Creek oil field to give you an idea where that's located near Baytown. Very interesting place for us in that over an 8-year period, we saw nearly 3 feet of subsidence occur, which in our area is some of the fastest annual rates that we've seen historically. That oil derrick you see out there in Galveston Bay certainly wasn't there. Wasn't wet when they put it in there, but that's just an example of what subsidence can do. In a coastal environment, certainly infrastructure damage, when we talk about wellheads, roads, bridges, canals, faulting. After this talk, I know all of us, we can sit down and talk and argue about which comes first, the subsidence or the faulting, or if they're related, or how that works, but certainly in areas where we've seen water level change over time, we see faulting occur, and structural damage can certainly occur through that, although we do have natural faults that occur throughout the region. Wetlands loss is one that people don't normally think about, but when you have an area that goes from slightly saline to saline because of a loss of elevation, that's a big issue for the environment. And then flooding, which is why we're all here today. I can tell you that subsidence doesn't cause flooding, but subsidence does contribute to flooding in some areas, and it's part of the puzzle as we look at all the components that deal with and impact flooding in our region. And that was one of the main reasons why we were created back in 1975. Some of these pictures, let's look at this this well up here. It's called a protruding well up here in the corner. For those of you that aren't familiar with it, that well wasn't pushed out of the ground around it sank. And we have other pictures of that later on in the talk, I believe. So one of the best examples of subsidence in our area is the Brownwood subdivision. Many of you are probably aware of that. We're going to zoom in on that. 1944, this is what it looked like with my crack aerial photography staff at Google Earth. They see the infrastructure going in 1944. This is planned to be a rather nice executive level of subdivision for folks working down at Exxon, and a lot of houses going in, infrastructure going in, and we fast forward to 1978, we begin to see the impacts of subsidence in the area. A lot of those homes were abandoned initially during that, and over time, all the homes went out, all the infrastructure went away, and if you look at it today, it's a nature park. It's a nice nature park. There's a little kayak trail that goes through there. But this is one of the poster child examples of subsidence impact on the landscape, and it's been shown everywhere from here to California to Nevada to Nagoya, Japan, and Venice. So it's one of those places people look at when they want to see an example of what subsidence can do to a region, particularly a coastal region. Here's that protruding well again, a little bit better picture of it. 15 years ago, I was at a HGS Subsidence conference, And I gave a presentation and talked about this particular photo. And I made the comment that if you look at this and measure the distance from the bottom of the wellhead to the ground, you get the maximum amount of subsidence that occurred in this region or in this area. And I was corrected rather quickly at that conference, because what we're really seeing is the minimum amount that could have occurred, because it's likely that that entire well also moved with the differential compaction in the aquifer. So this is a well in Baytown. It's been since abandoned and properly abandoned and everything, but it gives you a really good idea of what that impact looks like, and something that we want to avoid in the future. So getting to what the district does and how we take care of this problem. So our only tool to stop subsidence is to regulate the withdrawal of groundwater from the aquifer. And our way of doing that is by a way of regulating a portion of total water demand to an alternative source. And we've gone through several different iterations of how we do that. We beginning in 1975, initially right away with what was called the ACE, the Area of Concentrated Emphasis. And that basically was the coastal areas, and that's this 1975 figure up here. And then over time, we went through various complexities of regulatory arrangements. And basically what we were trying to do is identify those areas that either were or could in the future subside due to increased development and increased groundwater use. And we went through, we had 8, 9, I think at one point had even 11 regulatory areas at one point. Early on, we didn't think that we would have to regulate in northern and western Harris County because there wasn't a whole lot going on out there. But as development continued and as data began to be developed on how this aquifer was reacting to the stress of the system, we began to see that, yes, we were going to have to go out and look in those areas, and we were going to have to regulate those areas. And in 1999, we came up with the 3 regulatory areas: Area 1, near the coast; Area 2, which is just intermediate; and then Area 3 in northern and western Harris counties. And we set forth a plan to convert those areas from groundwater to surface water. Area 1 had already converted, and to give you an example of what those conversions look like, Galveston County and the rest of part of Area 1 went from about 60% groundwater at the time to 10% groundwater today. Area 2 went from what was 100% groundwater to 20% groundwater, and they were completed with that in the mid-2000 timeframe. Area 3 has begun that conversion, and right now they're at 70% groundwater and 30% alternative. And then in 2025, they're going to go to 40% groundwater. So a lot of conversions going on right now. We'll talk more about that here in a minute. How do we go about this process? Well, we develop our regulatory plan looking at population projections, and we base that information on the most recent census data. We just did this back in 2013. We took in the 2010 census data, brought together a lot of experts in the field, including folks from the University of Houston, and developed population projections, attached a projected water demand per capita to that, and then ran our groundwater flow models to identify what possible arrangements between surface water and groundwater would give us the best result in the shortest amount of time. And because of that, some of the things you see on this graph, and upper part here is just a line graph that shows you by area the population projection. And the story there is that in the areas near the coast, we don't expect to see a whole lot of population growth, but certainly in northern and western Harris County, we expect to see a whole lot of population growth. And if you look at this little cartoon down here on the bottom, it kind of gives you a color shade every decade about how we think that's going to play out. And for those of you that are from here, you know that this makes a lot of sense because that's where everybody's moving to, and that's the challenge that we all face as water managers and planners, is that we have an area that everybody wants to move to. It's a great place to live and raise your family, but it has resource limitations and resource consequences that have to be taken into consideration as we move forward. So I just went through the regulatory plan update. I will mention one thing that we do have one tool that we can use to ensure compliance. It's called our disincentive permit fee. So if someone is not able to comply with our regulations, either by choice or circumstance, then they are required to pay a disincentive permit fee, which right now is $8.46 per thousand. which is a high number for those of you that are in the water industry, but it's based on the City of Houston's highest contract rate. And we do that to incentivize compliance and incentivize moving away from groundwater to alternative sources of water that are certainly cheaper than that. So how has that worked? What's the results? And this slide gives you some ideas on how it looks. And I'm not expecting you to see the numbers or even look at them because it's more about the shape of those curves. As we move from top to bottom there on the right-hand side in those graphs, you're looking at total groundwater use by regulatory area. So regulatory area 1, which is near the coast and basically Galveston County. Area 2 is the middle graph, and that's the area just intermediate, the middle part of Harris County. And then area 3 is northern and western Harris County. You can see in area 1 and 2 where we've gone through full conversion. Groundwater use there has changed dramatically over the course of the last 43 years or so. And what we'll see later on is that the subsidence rates in those areas have shown a similar change. In area 3, we're holding on to a fairly consistent about 200 million gallons a day of groundwater being utilized today, but their next big conversion in 2025 will drop that number down considerably. And as we move through conversion, recognize that the conversion from groundwater to surface water is a process that takes time and resources, and those resources being dollars. And I'll talk more about that here in a minute. We work with a lot of different folks to gather information and collect data to understand the impact of our regulation on the water level in the aquifer, and then the impact of that water level on the subsidence rates that we see in the region. So we've worked with the U.S. Geological Survey since the beginning. We work with the National Geodetic Survey. We've worked with the University of Houston right now with their Earth and Atmospheric Sciences Department. They actually process all of our monitoring data for us, and it's a very, very strong collaboration with them. This right here is a landing page at the USGS. If you go and Google USGS Texas subsidence, you'll get to this page. And it has all of the water level data, all of the extensometer data that we've collected over the last few years, over the last 43 years, actually. And a lot of really good resource. And you can look at different intervals of water level change. You compare different years together, different aquifers together. There's a lot of cool things there. So I look forward, hope that you all get a chance to go take a look at it because there's a lot of useful information. Here's what it looks like if you look at from 1977 to 2017 in the Evangeline Aquifer, which is the most widely used of the shallow aquifers in our region. The blue areas are areas of water level rise. Those are also areas where we've seen full conversion occur over the last 40 years. So to give you some landmarks, this is Harris County. Here's regulatory area 2, regulatory area 1, area 3. These blue areas where you see increases upwards of 200 feet, 220 feet of water level rise in the Evangeline occurs in the areas where we've seen full conversion, but we look at areas out to the west where we're still working through the conversion process, and we see declines off of this historical benchmark in 1977 of over 200 feet in northern Harris County, in southern Montgomery County, and then out 160 feet or more out northern Fort Bend County in the Katy area, and then in the Jersey Village area. If we look at the similar water level change from 77 to 2018, it's a similar story. This is the most recent data. It's about to be, we just did a public hearing on this. We do a public hearing on this data every year. We just did it about a month or so ago. And this is the type of information that you get on the USGS website. Same story holds true. Water level rise in those areas where we've had full conversion, water level declines from the historical benchmark in the areas where we are still working through that conversion process. So we measure, so moving on from the water level change, which is a big component of this, because the water level tells us the pressure in the system and how that's changed over time. Looking at the compaction, there's a couple different ways you can look at compaction in the system. The best way is to have an extensometer. An extensometer is a mechanical measurement device that allows us to measure compaction over a specific interval in the aquifer system. And this is an example of one right here. This one's actually at the Addicks Reservoir. If you look closely, there's an inner stem and then there's an outer casing around that. Just to put it real simply, this outer casing has slip joints built in and is allowed to collapse upon itself. That inner stem is attached to a benchmark at depth. At this location, that benchmark's about 2,000 feet below land surface. And we monitor the movement of the outer casing relative to a fixed point on that inner stem. And we can very accurately monitor compaction over time. We also monitor that inner stem with this GPS antenna on top, so we can get information on if the benchmark at depth is actually moving. And the good thing at Addix is that benchmark doesn't move much, but we do see some movement here in the extensometer, so we know we have a stable benchmark there. This one in particular is right there in Addix Reservoir, and it's one of the extensometers that's seen some of the most movement over the last 25 or 30 years. The other way we measure subsidence is through the use of GPS antennas that are intermittently occupied at different benchmarks throughout the area. We have about 200 of these throughout the region with our help from the University of Houston. This essentially gives us the total amount of land surface deformation. So we can't isolate where the compaction is occurring in the system. We just know that we're seeing land surface change. So we monitor vertical and horizontal movement at these sites. The benchmark here is placed below that elastic zone, which is about 30 feet below land surface. So we try to isolate the area, try to get out of the noise of the shrink swell, the superficial clays that we see in the area. But various different types of period of records for these, because we put in a handful of these every year. We've been doing that since the 1990s. So one of the ways that we decided to begin to compare this information over time is to look at the rates calculated at each one of these locations, and that's what we'll show here in a little bit. Here's what that network looks like. There's other sites outside of this, and this little map up here kind of shows you the full network. This is where we're focusing on the map. Again, the numbers don't matter because these are just map numbers associated to a table. If you want more information on this, you can go to our website and at hgsubsidence.org and pull down the annual report. It has all this information in it. But essentially what we try to do is get information in areas that we know currently are compacting, and also look at areas that we think might be compacting in the future because of increased development in those areas. So we try to get ahead of development and ahead of water development in the region. As you can imagine, that can be a little tough because there's a lot of development going on. Here's what the annual subsidence rates look like from 2013 to 2017. So this is a 5-year period. Some of these sites go a little bit longer than that. Some of the sites that you see listed in here have a shorter time frame, so we try to isolate those that have more than 2 years of data. But the story is what you would expect. In the areas where we've seen water level rise, we don't see a whole lot of movement going on. In the areas where we see water level decline from the historical minimum, we do see current annual rates that are in the 2.4 to 2.7 and higher. That's in millimeters per year. So we get quite a bit of compaction occurring out in these areas and in the areas that you would expect to see that. If you look forward to the whole area, again, areas that are going through conversion are seeing that same compaction occur. So this is in centimeters per year, excuse me. Let you bring that in a little bit. So one of the questions that I get is, this is all great information for me now, but what does that mean for my total land surface deformation? How much subsidence has occurred? Well, we did some work back in 2005 and 6 to look at how much compaction has occurred throughout the region from 1906 to 2000. And we did that in a couple different ways. We compared some benchmarks between 1906 known benchmarks that are still in existence to today and to 2000, but we also looked at LIDAR data from Tropical Storm Allison and tried to come up with an estimate of how much compaction has occurred. And this is what was developed by Bob Gabrish, who passed away last year, but really was one of the fathers of the data set that we base a lot of the subsidence of research in the Houston area upon. He would certainly be the grandfather of the subsidence education and research in the region. Anyway, the Harris County in particular sees a broad area of about 6 feet of subsidence. For landmarks, this basically is about Beltway 8 to the east, to the west, and the Grand Parkway to the east. Areas down in Texas City, and then higher numbers down in the 10 range along the Ship Channel and in Baytown, in those areas where we've historically seen some subsidence occur for quite a while. But the big question is how much has occurred since then? Because the benchmarks in the area are hard to find stable ones. They move quite a bit. And to do level lines that are historical, typical transit leveling across the region is very expensive, which is why we've gone to using GPS data at our monitoring network. So what we've done is try to take our current rates and make some assumptions that those rates have been fairly stable since 2000 or in that range. And just make some estimates on what the current rates of what the current subsidence field looks like. So when you do that, you get a difference. You get this, and I'm just going to flip back and forth, and then we'll show them together. But you got that same six foot figure throughout the area. The areas to the east and to the south don't really change all that much. There's a broadening of this 7 foot contour that now extends in Jersey Village and northwestern city of Houston. Just between 610 and the Beltway. And the rest of these contours all kind of move out to the west and to the north. And I'll zoom in on that here on the next slide. Well, here's a comparison for those of you that like look at contours. Here's how it looks in comparison. Here's the 7 foot contour here. There's a 7 foot contour in the through 2016. And see, not a whole lot of difference out in this area. But you begin to see departure in those contours out here to the west and north. And when you zoom in on that, you can kind of see where that 1 foot contour is moved out. The 2 foot contour is moved out to west of Katy. The 3 foot contour is now moved all the way up into Montgomery County. This is important information because in these areas, we see that development is occurring and more water is going to be necessary. And it's important that because the regulatory position in those areas right now is to stop subsidence, that we maintain that course because these issues are moving out to that area. Take this information and factor in Harvey and the tax day flood and everything else, and you begin to see some similarities in those areas. So what do we do to fix this? So the district doesn't have the ability to move dirt. We don't sell water. We don't provide water. We're a regulatory agency. We count on strong partnership from our permitted community. And we get that from folks like the North Harris County Regional Water Authority, the West Harris County Regional Water Authority, and the City of Houston. Those regional water providers are going through the process to make this conversion happen. And they began the process several years ago. I don't know if many of you are familiar with this, but when the SWIFT funding was approved by the legislature a couple sessions ago, that was a big deal for the Houston region. That put a lot of low interest, low cost funding available to the region to make these infrastructure changes, to move water from Lake Houston and the Trinity River in there and around, all the way around northern western Harris County and into Fort Bend County to facilitate the needs of our regulatory plan and provide those alternative sources of water. So there's 3 projects that are going on right now. This is a multi-billion-dollar effort. And I'd give you a number. It's over a couple billion, but the number gets bigger as time moves on. Loose Bayou Innerbasin Transfer Project moves water from Loose Bayou, from Trinity River through Loose Bayou into Lake Houston. They're increasing the capacity of the City of Houston Northeast Water Purification Plant from about 80 MGD or 100 MGD to almost 400 MGD when they're done. And they're expanding the conveyance, which is the big part. I mean, you can get the water to Lake Houston and you can treat all the water you want, but you got to get it to where it's needed. And that conveyance is a very difficult project when there isn't a lot of commercial and residential folks in the way of those pipelines. So they're working really hard to get those right of ways and get those pipelines in place so that that conveyance can occur. And I just talked about both of those things. So these future alternative water supplies are important to the region, and they come at a cost. And many of you have seen those in your water bill. And we'll continue to see that cost go up. So as we move forward, not only does the proper planning on how much water is going to be required, but we also have to look at water conservation. Water conservation helps all of us. It helps the groundwater side and the surface water side, and can help your pocketbook at the end of the day. The district has put out some interesting things recently. I encourage you all to go to smarteraboutwater.org. There you can learn about different things related to water conservation. And the one really cool thing that we have that I'm really excited about is that if you go in there and you go to give me watering advice to how to water my lawn, it'll give you, based on real-time rainfall and ET data. It'll tell you how much you should water your lawn to keep it healthy, but also to avoid overwatering. Because I don't know about you, but in my house, most of the water I use in the summer is outside. And I had no idea how much I was overwatering until I actually started looking at this, and it was a very educational process for me. So I hope that you take the opportunity to do that. Some of the other things that we're looking at, we just finished a project looking at the desalination of brackish groundwater, and we just finished wrap that up, and that's very interesting for us because as we move towards these alternative sources of water, we're constantly mindful that the sources of water that we're moving to have more limitations than the groundwater sources that we have used historically. So we have to be sure that we've looked at every other eggs in the basket and be able to maximize those resources and look at other alternative resources that are out there. So we looked at that. Aquifer storage and recovery is another thing that's a big deal in the state of Texas right now. It's been talked about a lot, particularly since Harvey. The reality is in our system, there is no free lunch. Anytime you depressurize the system, whether it was depressurized long ago and the water levels come up, or are currently depressurized, you're going to see some form of compaction. And we're working through those projects to try to identify what the subsidence neutral yield of a successful aquifer storage and recovery project might be. So we're trying to give more tools in the toolbox for those folks that are charged with providing water, and giving them every opportunity we can to stay compliant with our regulatory plan, because we know that if we do that, the subsidence rates throughout the district will become asymptotic like we've seen down in area 1 and 2. And with that, I will conclude. Thank you.